Hi students, problem number 6 in connected bodies. If the strings are light, inextensible and the pulleys are smooth and frictionless, find the acceleration of the blocks and the tensions in the strings. So here is an arrangement. There is a horizontal table surface over which 2 kg bars is kept, and there are two pulleys fixed to the two ends of the table. Over the pulleys, a string is passing over, and at the two ends, 5 kg and 3 kg blocks are suspended. In the middle, there is a 2 kg block. Now, what is going to happen? The left side block is having a greater mass of 5 kg. The right side is having 3 kg, okay, which is less than 5. Therefore, the 5 kg block will be accelerating in the downward direction while it is pulling the 2 kg towards the left. So, there is a tension T1 in the left part of the string, and the 3 kg mass is accelerated in the upward direction, and there is a tension T2 on the right side part of the string. So we are connecting the three loads to the same string, so the acceleration of all the blocks will be equal. Only the tensions T1 and T2 will be different. So we are supposed to determine the values of A, T1 and T2. So for that, for the three given masses, I have drawn the free body diagram. Now look at the free body diagram for the mass 2 kg. So this is 2 kg mass. So on this left side, greater tension T1 is acting, and on the right side tension T2 is acting, so that here T1 is greater than T2. Okay. So left side is T1 and right side is T2. Under the action of these two tensions, the 2 kg mass is accelerated in the left hand side. Therefore, T1 minus this T2 must be equal to this mass 2 into A. So, this is equation 1. Next, coming to the free body diagram of the 5 kg mass. It is accelerated in the downward direction. Therefore, this 5 times G, 5G, its weight is 5G. Minus T1 must be equal to 5A. So, for this 5G minus T1, and that is equal to 5A. Now, let us take G is equal to 10 meter per second square. So, this is 50. 5 into 10 is 50 minus T1 is equal to 5A. Or T1 is equal to 50 minus 5A, and this is equation 2. Like that, now you draw the free body diagram for the 3 kg mass. Its weight 3G is acting in the downward direction, but the tension T2 is acting in the upward direction. Acceleration also is upward. Therefore, T2 minus 3G must be equal to 3 times A. So, T2 minus 3 into 10 is 30 is equal to 3A. Therefore, T2 is equal to 30 plus 3A. And this is equation 3. So, equation 2 is for tension T1 and 3 is for tension T2. I am going to substitute that in the equation 1. So, T1 minus T2 is equal to 2A. So, instead of T1, I am going to substitute 50 minus 5A. So, T1, 50 minus 5A. Okay, minus of T2. T2 is what? 30 plus 3A. So, this is a 30 plus 3A, and that is equal to right hand side is 2A. Now, this is 50 minus 30. So, 50 minus 30 minus 5A minus 3A. And that is equal to 2A. So, 50 minus 30 is 20. 20 minus 8. A is equal to 2A. So 20 is equal to 10A. Therefore, A is equal to 20 divided by 10. So this is 2 meters per second square. So first we have determined the acceleration of all the 3 blocks, that is equal to 2 meter per second square. Then I am going to substitute the value of A in equations 2 and 3. So we can get the values of T1 and T2. So T1 is equal to 50 minus 5A. So this is 50 minus 5 into 2. This is equal to 50 minus 10. So this is equal to 40 Newton. T1 is equal to 40 Newton. Okay, therefore T1 is equal to 40 Newton is the answer. Similarly, you take equation 3 to determine T2. So T2 must be equal to what? 30 plus 3A. So this is 30 plus 3A. So this is equal to 30 plus 3 into 2. So this is 30 plus 6. This is equal to 36. Therefore, T2 must be equal to 36 Newton. Okay. So in all these type of pulley and load problems, you will have to draw the free body diagram and mark the directions of the acceleration correctly. Then you will be getting the correct answer. I hope you must have understood well. Fine.